Hello guys, thanks for watching my video. Today, let's see the sum special values of gamma function. Okay, then is half argument, you can say, right, or half value, something like that. Okay, now we are going to evaluate, or we are going to prove number one, gamma half. Okay, one is gamma of half is nothing but the square root of pi. Okay, how did we get this one? So you may say, how to prove, right? Something like that. So yeah, we are going to see that. Okay, using Euler reflection formula that we have already done. So then is Euler reflection formula is nothing but gamma s, gamma 1 minus s is nothing but pi over sin pi s, right? So applying this, putting s equal to half, we have gamma of half, gamma of 1 minus 1 half is equal to pi over sin pi over 2, right? So pi over sin pi over 2 is just 1. Then is sin 90 degrees is just 1, right? So it is pi. Therefore, gamma half and 1 minus half is again half. Wow, this is nice, right? So gamma half is pi. So gamma square of half is pi. Therefore, gamma half is the square root of pi. So the gamma of half is the square root of pi, right? Wow, this is nice. Okay, and I think without using reflection formula also you can prove in many ways. Okay, anyway, I'm using this Euler reflection formula for the shortest proof. Okay, so therefore gamma of half, so in terms of factorial, gamma of s is s minus 1 factorial. That, right? That I have already, I include that in property, I think, right? Property of gamma function, right? Therefore, gamma half, so in terms of factorial, this will be negative half factorial, right? Negative half factorial, which is the square root of pi. So, okay, now then is gamma of half is negative half factorial is square root of pi, right? Now then is the first one, no, second one. One is gamma of negative half. Here is positive half, here is negative half, okay? So we are proving, we are going to prove that gamma of negative half is negative 2 times the square root of pi. Okay, I'm going to use this, okay, gamma half. Now using that, gamma of s plus 1 is s gamma s, right? We know this one. So gamma s is nothing but 1 over s gamma s plus 1. That means dividing both sides by s, okay? Then you get gamma s is 1 over s times gamma of s plus 1. Now putting s equal to negative half, we get gamma of negative half is equal to 1 over negative half. Gamma of negative half plus 1 is equal to, this is nothing but negative 2, right? Negative 2. And gamma of negative half plus 1, that means 1 minus half is half, right? So gamma of half is here, we have already evaluated in 1. Gamma half is the square root of pi. Therefore, you get negative 2 the square root of pi. Wow. Right. Therefore, gamma of negative half is nothing but, in terms of factorial, it will be negative 3 by 2 factorial, okay? So this is negative 2 times the square root of pi. Now, the third one, okay? Then is gamma of 3 by 2. Here we evaluate gamma of half, gamma of negative half. In the next, we are going to evaluate gamma of 3 by 2, okay? So gamma of 3 by 2 is half of the square root of pi, okay? Now, without further delay, let's use gamma of s plus 1 is equal to s gamma s, okay? Putting s equal to half, we get gamma of 1 by 2 plus 1 is equal to 1 by 2 gamma of half. 1 is gamma of half is the square root of pi. So the 1 by 2 the square root of pi. And gamma of 1 by 2 plus 1, then is 1 plus half is 3 by 2, right? Gamma of 3 by 2. So in terms of factorial, it will be half factorial, right? So which is equal to 1 by 2 times the square root of pi. And we prove the third value for gamma function. Now the fourth one, okay? Here gamma 3 by 2, here gamma negative 3 by 2, okay? Is nothing but 4 by 3 that times the square root of pi. Now using that gamma s plus 1 is s gamma s, so gamma s is 1 over s gamma s plus 1. That means dividing both sides by s, putting s equal to negative 3 by 2, we get gamma of negative 3 by 2 is 1 over negative 3 by 2, gamma of negative 3 by 2 plus 1, okay? In place of s, put that negative 3 by 2. Then you get negative 2 by 3, gamma of negative 5. Gamma of negative 5 we have already here, right? So gamma of negative 3 by 2 is negative 2 by 3 times gamma of negative 5 is negative 2 times the square root of pi. Negative 2 times the square root of pi. So negative positive. So 2 to the 4 by 3 the square root of pi. Therefore gamma of negative 3 by 2 is negative, in terms of factorial, negative 5 by 2 factorial, which is 4 by 3 times the square root of pi. Okay, that is what we are trying to prove for this gamma function. Okay, let me talk something about this gamma function. So this gamma function is this one. This gamma function, okay, this gamma, why this gamma function came out is that, so when dealing with this factorial function, okay, factorial means number of ways, okay? So example like 0 factorial is 1, right? 0 factorial is 1, 1 factorial is 1, 2 factorial is 2, and so on, right? That means it is, this factorial function is for particular value of this factorial function, there's only this positive integer with 0, right? That means whole number. So that means we cannot have negative 1 factorial, right? So negative 1 factorial. So that means for negative integer, for negative integers, this factorial function is it does not define, okay? This is not defined. That means this factorial function is defined only for positive value, okay? Positive integer we can say, right? But this gamma function came out due to Euler, okay? Due to Euler. So this, and again we already proved in the previous that gamma s is s minus 1 factorial. That means this gamma function and factorial function are related, right? So that means we can say, so according to that in the source, okay, so gamma function is nothing but the extension of this factorial function, okay? So this factorial function only study for positive integer, but gamma function study for negative also, right? Here, right, negative value. So negative half factorial meaning negative 0.5, right? Negative is study for negative, but this factorial does not study for such type negative, right? And again does not study for this half, right? 1.1, 1.2, something like that, right? So the gamma function came out. So that's why now we can study half factorial, negative half factorial, negative 3 by 2 factorial. This is 1.1, this is 0.5 factorial, minus 0.5 factorial, right? And this is minus 1.1 factorial, and this is 0.5 factorial, right? Then it's half factorial, and this is 2.5, right? Minus 2.5 factorial. So we can have like that, okay? That's it.